Research is the generation of new information, and of course nothing wants to remain static. And to progress in our understanding of the world and ourselves and our reason for being, one needs to constantly keep studying all these subjects.
Delbert Day and his student Steve Young at Missouri University of Science and Technology are greatly advancing the understanding and use of bioactive glass.
This is a piece of the material that we're actually using in the wound study, and it's pretty different than what people would think of glass. It's actually, as you can kind of see, I'm moving it here, it's a lot like cotton. The fibers are so small that you can bend them and kind of form them, and it's a completely different type of material. It's got different chemicals in there. There's the boron, there's some calcium, potassium, sodium, there's some phosphate, magnesium. And a lot of these things, they sound, you know, if you picked up a vitamin bottle and you looked at it, you'd say, hey, there's a lot of that stuff in here. And so we think that the release of these different chemicals from the glass right at the site where they're needed is really what's benefiting the wound. We've been able to help people on a personal level. You know, they're, according to the wound nurse, I mean, they're in much better spirits, they're very happy with what's going on. I mean, they just, you know, for some people they've had wounds for years, had no progress, all of a sudden now within a few months, it's gone. And they're just ecstatic about it, they love it. So just the fact that we can help people, I mean, that's what we do here. I mean, all the research in the world, it can be great, but if you don't help people, what's the point?
At the University of Missouri, Kansas City, Dr. Chin's fight against breast cancer started from a very personal observation.
One of my auntie got breast cancer. So that's a major reason I'm interested in breast cancer. Cancer is very complicated. Right now, we still don't know what causes cancer. But we know that many genes, if the genes has a different expression, it can cause cancer. So therefore, our strategy is to change the gene expression.
Dr. Chin's lab team is refining ways to block cancer cell genes from being expressed, which will turn off the cancer tumor's ability to reproduce and grow. Unlike conventional chemotherapy, this biomedicine will not have severe side effects and only target cancer cells.
We add a ligand, another small molecule, and this small molecule can only bind to the tumor cells. So we link the small molecule to the biotech drug, and then it can bring the drug specifically to the tumor cells, and it will not harm any normal cells. We did see some very promising results. So right now we are working on the animal model. So we try to implant the tumor cells in the mouse, and then once the tumor is formed, we will inject the drug into mouse.
Dr. Chin believes the University of Missouri fulfills many vital roles.
Public university plays a very important role in the education system in the United States because that opens the door. It provides opportunity to most of the young kids in this country so they can get the chance to get higher education. So that will be very helpful for their future. And also our research is related to the public health, and especially in Missouri, the breast cancer, there are many breast cancer patients. So if we succeed in our project, that can benefit these patients in Missouri and also in this country.
The MU Research Reactor is actively involved in developing products such as radiopharmaceuticals. Last year, they supplied over 35 different isotopes, many of which they are the sole source provider. With breakthroughs in nanomedicine, the MU Research Reactor is working to produce radioactive gold nanoparticles, which offer promise to fight prostate cancer.
That was a project originally looked at by Kitesh Kadi and Raghu Kannan. And we've been interested in looking at radioactive gold for quite some time. And so working with Kannan and them, we basically developed a method that you can do it in a really small time frame, like a minute. So we can make radioactive gold nanoparticles using solutions that are very friendly, using even green solutions. Make these and make them in such that they're very stable and that we can easily introduce them into humans and they're not toxic. The nice thing about the nanoparticles is that we can size them such so that we can do it with 1 or 2 introductions. We can get a uniform dose into the prostate, and what we've been able to show is we get a higher reduction of that tumor size than you can get with just the normal, even with the lower amount of radioactivity.
Being part of the university family allows MUR researchers to collaborate with faculty and researchers across many disciplines.
We have people who are doctors from Ellis Fischel. We have people from veterinary oncology that are working in here. We have people from chemistry. We have experts in nuclear engineering who are helping us size the particles. So it's a large collaboration of people who come together and help to address specific parts that they're the expert in, which allows us to move that project so much more faster than it would be if you have one person who then has to try to develop the expertise at each point. The reason this facility has been here for so long is the innovation shown by its employees and understanding what the marketplace is needed.
Septic shock is a big problem around the world, and it has a mortality rate of about 40 to 60%. So if you start to show symptoms of septic shock, you're in pretty bad shape.
2 University of Missouri St. Louis researchers are working on a way to turn off our immune system when it overreacts.
So when you have a bacterial infection, you have actually the presence of bacterial cells in your body. And what it does is it causes macrophage cells to flood into the area where you have an infection.
We've been working on compounds that are specifically targeting this receptor that's called CD14. These molecules mimic the structure of carbohydrates that are present on the surface of E. coli bacterium.
By combining their knowledge and the expertise of both of their labs, they have found a simple and reproducible carbohydrate to block the C14 receptor from the effects of E. coli fragments.
I think what's really important in science right now is collaboration between different disciplines, whether it be chemistry, biology, physics. It's hard to solve problems now with just one focus, and so collaboration between different labs that work on different things is very important.